Right.
Okay. Hi, everyone. Welcome to our Database Cloud Services Office Hours. My name is Tammy Bednar. I'm a Senior Director of Product Management focusing on Database Cloud Services. I'm really excited today to have this topic and have our great speaker, Keith Laker, with us today to talk about directly accessing data lake files and object stores using Autonomous Data Warehouse. So I think this is a great topic. We're always talking about how we can move data into the cloud and easily access it for whatever those business needs are, because we seem to have, as companies grow, we seem to hoard a lot of data. I don't know if we want to call it a hoarding, but we seem to capture a lot of data anymore, and we want to get a lot of value out of our data. And I think Keith has some great ideas on how to be able to access this data, get value out of it, and help the business. Again, if you have any questions, please put them on chat. If you raise your hand, I'll unmute you, and we're happy to have a discussion with you today. So, Keith, for today, you want to get it started?
Okay, thanks very much, Tammy. Yes, good afternoon, everyone, or good morning, depending on which time zone you're in. I'm part of the database product management team, part of the team also that delivers Autonomous Database. Although we have two flavors of Autonomous Database, I'm going to focus primarily today on Autonomous Data Warehouse, because that's the typical platform where you're going to see data lake patterns being developed. So, oh, my buttons are not working. Next slide. What happens if I do that? Okay, good. So I'm going to go through some topics today. I am going to stray into some areas where we've not released some functionality, just to give you some idea of the direction we're going with the future Autonomous Data Warehouse and how it's going to support data lakes going forward. So I have to put this up just as the caveat. We may deliver what I'm going to talk about, we may not, so don't rely on what I say. Okay, the agenda, I'm going to look at some key things like overview. Okay, what is a data lake? What is the difference between a data warehouse and a data lake? And once we've established that, we'll look at, okay, what typical formats do I find in a data lake when I'm looking at the file types that are in that lake? Where do I put those files in my lake? Is there a particular type of area that I have to put them in? Is there a particular service that I use? Is it unique to Oracle, or can I step outside of Oracle and use someone else's service? Then, okay, how do I design my Autonomous Data Warehouse so I can actually see these files and query them with SQL? And then, having designed it and used some of the new capabilities that we've put into Autonomous Data Warehouse, particularly the new 19C release, which you should see in your data centers now when you go to provision an Autonomous Data Warehouse. So once you've sort of set up, if you like, the shell to be able to go out and look at your data lake, how do you validate that design and make sure that everything is functioning, so that when we go in to write some SQL, or we go to our BI teams and say, right, okay, put your Oracle Analytics Cloud on top of this and start writing queries, that all the data is going to flow smoothly. So what's the difference between a data warehouse and a data lake? There's a really good blog post on this by Sherry Chow, who works at HQ, and she's lays out the basic differences between these two big scenarios, these two big patterns that we're seeing for autonomous. So if we look at a data warehouse, probably everybody's familiar with that. It can be structured data, but these days we're multi-model inside Autonomous, so you can have unstructured in there, but typically the data's inside the database. Primarily that's what it's designed to do. There's a very rigid data model on top of that, although it can be loose, and it's bringing together data from typically other databases into a single place so you can access it. And you typically got multiple subject areas. You might have sales, you might have some finance data, order data, product data, customer data, so on and so forth. The data lake is a bit more diverse, shall we say. You've not only got tables with columns and rows in there, you've got all sorts of data types in there. You've got JSON data, you've got XML data, as we'll see going forward. But it's very, very flexible. How it looks today may well change tomorrow. There may be new attributes coming in. There may be new files arriving from new sources that have to be brought in. So it has to be very flexible. The data is ingested very, very quickly through SQL, in this case, within Autonomous, and people access it on the fly. What they look at today may not be what they look at tomorrow. So it's very flexible, fast moving, and typically pretty big. And there are a lot of different systems pushing data into it. So if you look at a typical platform, you're going to have pretty much all sorts of data sources coming in. There may well be some sort of ingestion system, some sort of stream, or some gateway that allows that data to come in, either from other relational systems, or maybe it's Internet of Things, maybe it's a web service, and then that ingestion process will then look to persist that data somewhere. So it's going to take it and just put it somewhere that you can then access time after time after time. There'll be some metadata around that. Okay, what's the file name? When was it landed? How many columns? What type of data's in there? What information do I have about that data and the data types? There may well be some processing, and we might lose some information, we might gain some information, so we might enhance it. And then there's setting up the access paths. How do I get the downstream systems to then pop into that? And then you've got all your downstream visualizations. Now for this, although we've got a very big data lake capability inside the Oracle Cloud, for this specific pattern that I'm going to look at, I'm going to look at taking data that's effectively in our object storage layer that has come from some sort of data integration process, either it's ODI or it's a streaming service, a Kafka service, whatever it is, OCI streaming, that's pushed that data into some sort of persistence area. That could be NoSQL, it could be a big data service, it could be autonomous transaction processing, it could be another autonomous data mart, or it could be going into our OCI data flow process. Those will then do whatever they need to do. Maybe there's more processing that they do on their side, and then put out information to an object storage. Metadata about that object storage is, or will be, consumed by the catalog. That process is ongoing at the moment. We announced that at Open World. And then, if you like, the front end access, how we're going to make this available through SQL to our data science team, our business teams using Analytics Cloud, even our apps environments using Fusion Analytics Cloud, is through Autonomous Data Warehouse. So that's the data lake. That's sort of how we would build the data lake. So if we assume that the data lake is built, I've got all these files accumulating, and now I need to be able to start working with those. So what are the file formats that we support if I want to put something over the top of this environment? There are a basic set of building blocks here. So we have things like CSVs, comma delimited, standard text files. We've got slightly more complex structures like JSON, Avro, and then we've got very complex structures that can do a lot for us with things like Parquet. So there's like a standard set in most data lakes. Those are the typical formats that you're going to see. There are some other ones. You can get XML coming in here as well, but XML seems to be on the wane and JSON seems to be on the up. So we'll stick with that list. As I say, Parquet is probably the most interesting one. Simply from it fits quite nicely into the autonomous mold because it allows us to very easily integrate data sources with sort of minimal interaction. It's a columnar format, so the actual file itself holds an awful lot of information about what is inside that Parquet file. And we can leverage that to provide very simplified access to that Parquet data set. And the way that Parquet works and the way it's organized allows us to get much faster query performance compared to, say, a comma delimited or a JSON file, simply because there's a lot of information in there that we can make use of for doing eliminations. So let's have a quick look inside a Parquet file. If you're not aware of or you're not familiar with Parquet, this is what a typical Parquet file would look like at the start of it. In the header, I get information about the data set within it. So I know what my columns are. So I've got prod ID, cust ID, time ID. And I know what the data types are. So I know that prod ID is integer. I know cust ID is integer, time is binary, so on. Now, what that allows us to do is, rather than ask you, okay, which columns do you want out of this table and get you to type all this in, we can actually inherit that information directly into the autonomous database. So when I go out, we'll have a look at this construct in the middle, this DBMS cloud create external table in a minute. What you'll see is that because I can say type Parquet, so I understand within autonomous database that there is a file type Parquet, and that file type has a lot of information that I could use. I can just say, okay, here's the file. You get all the information that you need from that file and build the table for me, please. And that's all the input. The only thing I need to give it really is, what do I want to call this? And I'm going to call it sales. And it will do all the database, the autonomous database will do all the heavy lifting for you to create that table and populate it. The nice thing about Parquet is that we can do some additional processing. So when I go to query a Parquet file, I can do certain things that if you're used to, say, things like zone maps and Exadata, I can do things like column projection. So if I don't need prod ID, I don't actually have to gather all the information from prod ID. I can ignore it. I can also do predicate-based row elimination. So if I only want where the cust ID is 1, I can do that processing as I go and access the Parquet file. So all of the metadata that's in there, in the sort of the header part of that file, allows us to do some really clever things with it, which means you get really good performance. Okay, so we know what the file types are. So we know we can do text, CSV, delimited, JSON, XML, and we've got Avro and Parquet, which are the very much the data lake style files that get come out of a lot of big data type applications. We can process those. We know that we can get performance benefits if we go for files like Parquet. Question is, okay, I've got these files, they're being generated by those applications that are in my data lake area. Where do I land those? Where do I persist them so that my autonomous database can now run SQL over them? Typically, you're going to use an object store. So with Oracle, if you've got a cloud account already, you'll know there's the Oracle Object Store. And there are 2 key elements to this. Now, what I have behind this slide is a whole stack of hidden slides. So if you're not familiar with Oracle Cloud or some of the other object stores that I'm going to look at in a minute, it will give you all of the screenshots. So if I want to go to an object store and create a bucket, it'll say, go here, push that, create your bucket. If I want to do, okay, how do I authorize my autonomous data warehouse to get access to that bucket? I've got all the screenshots that say go here into identity management, click on this link here which says auth token, so on and so forth. I'm not going to go through all of that in this webcast, but I'm going to talk through it, and the slides when they come out will have all that information for you. So you need to have the object store, you need to have a bucket, and you put the file in the bucket. The object store has command line access to upload the file into the bucket. So you can then, you have an API that you can use. If you want to automate this through, say, ODI, or if you want to go straight from a streaming service into the object store bucket. And then you, because we're in the cloud, you need to authorize access to that bucket and the files within that bucket. So then we have to step out of the object store and we step into identity management. And we go through and we create what's called an authorization token, which we can then use, which is going to say to the cloud, I am authorized to query this bucket and access this file for processing. So what you'll do is you'll look at, in the identity management, you'll get your username, your full username, which will be something like Oracle Identity Cloud Service, stroke username, whatever that is. The authentication process will create what's called an auth token. So you'll go into our identity management, you'll see on your user account the ability to create an auth token. That will pop up, say your auth token is this, take a copy of that. Then you come into your autonomous environment and you create a credential that's going to allow autonomous data warehouse to look at your bucket in the object store and be authorized to then see what files are in there and access those files through SQL. So you're going to use this DBMS Cloud create credential, give it a name, set up your username, use that password that you just copied, and you're now authorized. Now we support other object stores. So we know a lot of customers already have files, already have streaming systems. The data lake doesn't just have to reside in the Oracle Cloud, it can be multi-cloud. And this is probably the big difference about data lakes in the cloud is compared to data lakes on premise, the data can now be anywhere in any cloud service, or so you need to be able to access those. So if we go hop over to Amazon, I may push files into there, into S3. So again, you're going to need an object storage area. So you'll need to go into S3, create a bucket, and then you'll get an object URL for your file once you've uploaded it. Then again, you need to step out into the Amazon Identity Management, Identity Access Management in this case, and get a key ID again to authorize access to your buckets. So you'll get another create credential, whatever you want to call it. I've called it Amazon S3 Object Store Credential. I get my username, which is my IAM access key ID, not my Gmail account or whatever it is that I've used to sign up to Amazon to get into Amazon Web Services. There's a unique access key ID here, and you'll get an associated secret access key password. So those are the two things that you will need. Again, when we upload this, I'll have the screenshots that say, click here, go in here, get the key, click here, get the secret access key, copy that, so on and so forth. As I said, you can be multi-cloud. So not only do we support Amazon, you can also go into Microsoft's Azure storage, Blob store in this case. And for this, again, there are two services. The Azure storage, the Blob store, in which case you'll need a resource group. And that's going to manage the storage of data files within containers. So there's a resource group, there's a container. Within the container, you will then get access to your URL file. And as before, as with S3 and with our object store, you need to authorize access to the resource, to the container, and to the files. And in Microsoft, there are two access keys, potential access keys that you can use, key 1 or key 2. So again, my storage account name goes into my username, and my storage account name access key, I've used key 1 here, goes into the password section, and that now allows me to reach out to Microsoft Azure storage. So that gives me my, if you like, my authorization now to go into my object stores where I've landed my supported files, whether they're Avro, JSON, Parquet, whatever it is. The next part is, okay, how do I get access to those files? So slide 18 is which I think is that one. Is that slide 18? Yes. Is the command being run on ADB in this example? It's a very good question. Yes, it is. So what I've done is I've gone into the Oracle Cloud, I've signed in, I've gone to Autonomous Data Warehouse, I have clicked on my Autonomous Data Warehouse that I want to access, and then I can do one of two things. I can either download a wallet, which is going to allow me to set up a desktop tool to access my Autonomous Data Warehouse. That could be SQL Developer, for example. And then with that wallet, I can then access my Autonomous Data Warehouse. And then in the SQL worksheet in SQL Developer, I can paste these commands in, and it will create the necessary credential within my Autonomous Data Warehouse to access, in this case, a Microsoft Azure storage. If you don't want to install a desktop tool, within the Autonomous Data Warehouse console, within the Oracle Cloud interface, there is a series of tools that we provide, including SQL Developer Web. So you can do this, you can open up SQL Developer Web, and then take these commands and run those in SQL Worksheet, in SQL Developer Web, direct in your browser without having to go into any desktop tools. So all I'm doing at this point is, in my Autonomous Data Warehouse, where I'm building access to my data lake layer, I'm authorizing myself, my Autonomous Data Warehouse, to use specific accounts and specific keys to either go into Microsoft Azure's Blob storage, Amazon S3, or Oracle's object storage to access files. So I have the access now, I have the capability to reach out to those object stores. The next part is, okay, how do I design my tables to be able to go out and reach out and grab those files and start querying them? So I said there's various file types that we can support, and if you use SQL Developer Desktop, it has a really, really nice, easy to use import wizard. So you log in, you connect using the wallet, and SQL Developer is autonomous database aware. So it has a lot of features in it that are very, very useful for connecting and managing an autonomous data warehouse. One of the really good things is this SQL Developer import wizard. So I can take either a CSV, a delimited, or a text file, and step through a wizard that's going to ask me for my credential. Okay, how are you authorized to access this particular object store? It'll ask me for the URL for that file from that object store. And then it will do a quick test. Okay, can I access it? Yes, good. And it will bring out, it'll sample the first part of it and show you, okay, this is what we think the file looks like. And you can then tweak it. So maybe it's semicolon between each column that delimits each column. So you can tweak various parameters, and it will do a first cut of saying, okay, I think what you've got in here is employee ID. We'll scan this, we think number, and we think 5 is good enough. And job ID, it's varchar 2, will give you 128 characters. That should be sufficient. Now, if you know the data well enough, what you typically find is 99.9% of the time, the way that it samples and works out, okay, employee ID number 5 is going to hit the mark every single time. There may be a few exceptions, and we'll look at that a little bit later. So this will get you in. It will do CSV text and delimited, and you probably spotted already that some of the file types are not there. It will define the table for you. It will define the column names. It will define the data types for all these columns. And then in the column definition section, you can very quickly go in and say, actually, where my table said emp ID, I'd like it to say employee ID. Where it said MGR ID, I'd like that column to be manager ID. So there's flexibility there for you to go in and redefine your columns and also the data types. And then the really nice thing here is you can now go and test it. Is this going to work? So I don't have to wait until I've built this table and then try and run a query against it. SQL developer will run a test query for you. And you can pick the number of rows you want to check, and all being well, it should work first time. Usually does. Most of the time, 99.9% of the time when I try this, it gets all the columns in the correct date type, and I hit test and I get success. So at that point, as soon as you're ready, you can just say finish and it's off. For some of the more complex types like JSON, Avro, which have very, very flexible data structures. So it's not unusual for developers that are doing big data type or new web-based applications or Internet of Thing operations will typically use one of these file types, JSON. Pure and simply because I can add in new attributes, I can take out attributes, I have tremendous flexibility with how this file gets written and the contents of the file without having to worry about what did the file look like yesterday. So I have the flexibility to decide what are the attributes within this schema. Consequently, we have to do a little bit of manual operation here to get some of these more flexible data types coming. We're working to try and speed this up and make it a little simpler, but because of the capabilities within there, these are relatively straightforward file types to build. It's not a complex piece of SQL. As I said, the nice thing about things like Avro and Parquet is that everything I need to know, for example, like has it got employee ID in there, job ID, what should the file type be? Should it be varchar 2, 128 or number 5? All of that information is actually inside those files. So they're actually inside the Avro file or inside the Parquet file. So I can just direct this statement, this create external table, which you like is my data lake definition process. I can just point them at that, and it will go off and gather all the information for me. So this create external table is going to do all of the heavy lifting for me of working out what the table should be called, which I've set as movies_ext, what the columns need to be, what the data types need to be, so on and so forth. And it's going to do all of that for me. Similarly, if I've got Parquet, I just point to my Parquet file, it's going to do all of the heavy lifting for me. Now for here, I'm in my Toronto data center on the top one for the Oracle Object Store. This could be S3. I could be in an Azure Blob storage. I could be running Oracle Object Store to get movies EXT data, and I could be running Azure Blob Store to get my extended sales data. And I can query and join across data that's in Azure and query that's accessing data in the Oracle Object Store. This is the beauty of having this data lake built within Autonomous. So before we move on,
there is a question. I thought it's a couple of good questions. One about these APIs. The DBMS Cloud, it's available in more than just Autonomous Data Warehouse, correct? This package.
That's the idea, is that we're going to make this available as a general cloud package.
Okay, awesome. That's great. Thank you for asking that question. Eric also had a question. You've been talking about SQL Dev Web and SQL Developer, your package that you install on your laptop. We automatically update SQL Dev Web in the cloud, correct?
Yes, we will take care of the management of that.
Okay, fantastic.
So once we get a new version from the SQL developer team, it will get scheduled to go in, and you'll get a notification. There's a maintenance run this weekend. We're doing this, and SQL Developer Web will be maintained, patched, upgraded by us automatically for you. You won't have to download anything or install anything. It's all completely managed within that Autonomous framework.
Well, that definitely makes it nicer, so that you don't have to.
Yes, makes it a lot easier.
Cool. And Sanjeev, we expect that we continue to add updates to our cloud services pretty much every month, sometimes every quarter. So the cloud moves quite rapidly. So as the package is updated and tested in all the cloud services, then they get added. Please stay tuned to the documentation as we release it as well. Okay, Keith, thanks. Keep going.
Okay, thank you. For JSON, and I know a lot of developers, this is the language that all developers use these days. How do we get JSON data in? There's a great blog post, Nilay Panchals on, he was on, you may have switched to being an attendee. Nilay's also one of my colleagues in the Autonomous Database Product Management team. He's got a fantastic blog post that will walk you through the whole process of, I have a JSON file, how do I access it now? So this is like a snippet from that. So I have my create external table, and you can see here it's a bit different to doing a create external table on Parquet or Avro. So the only thing about JSON is it's tremendously flexible, but it doesn't have all of the metadata that we have inside a Parquet or an Avro file. So we have to do a little bit more work here. Things to note here is, okay, I've got my table name, I'm going to call it JSON channels. I've got my object store credential there. That's going to authorize me to go into, in this case, my object storage in my Frankfurt data center and access this file, which is channels export JSON. So I'm going into our Frankfurt data center. My ADW could be in Toronto, could be in our Melbourne data center, could be in our Jeddah data center. Doesn't matter. Doesn't matter where the Autonomous Data Warehouse is. or where your object store files are. We can get them from any of our data centers. I'm going to point out to the system my create table that it's CSV, and then what you'll see is, unfortunately in JSON there is this tremendous flexibility. So I have to tell it, okay, these are the key and attributes that I'm interested in inside this particular file. So I need to know what's in there. And typically if you look at a JSON file, it's fairly easy to look at the key values and see what the information is that's in there. So when I've got a channel ID, I've got a channel description and so on, and that's what's inside my JSON file. What I need it to do with that is to create me a container, a table inside my autonomous data warehouse that's got a channel ID of type number and a channel description as varchar2. So you've got to do a little bit more work with JSON, but as I say, it's fairly easy to understand it. JSON files are not that complicated, but it is, unfortunately, at the moment, a manual process. That will get fixed later on. Okay, so the table that you create, the ones that we've done so far have just been very basic tables. You can see here, I told it, okay, I'm just going to create a table, external JSON channels from this file. In the similar way that we've got different types of files that live in our data lake, I've got different types of tables that I can use to access the different files. So I may have a whole series of files that I need, for example, to look at my sales data. They may be divided up by month because that's how they arrive, or it might be every day or every hour. And what I'd like to be able to do is, because of the way that I'm going to query them, I might be always querying the latest one. That's the one that everyone's interested in. How many widgets did we sell in the last hour, or today, or yesterday? I might break all this up and I'll put each file in its own object store bucket, or they may all be in the same bucket with different file names. And then I can chop up my table. I can partition it. So if you're used to Oracle database on-premise, it's exactly the same in the cloud. So we're using exactly the same technology. It's exactly the same database. We're just doing all the management for you. So we provide you with the same flexibility. You can partition that table, and you can point each partition to the file in the object store bucket. Now, what this gets you is, if I do only want to query, for example, the latest sales data that I'm maybe partition 03, file 03, I can go straight to that. I don't have to touch file 01 or file 02. I can just go straight to that particular bucket. So I can get rid of a whole load of processing that's not relevant to me. So when you query that partition table, it's going to be magnitudes of faster for query performance, because they don't have to go through all of the data and then throw it away, the bits that I don't need from file 1 and file 2, because actually all the data I need is only in file 3. Now, if you're a DBA, what you're typically used to doing is, okay, I create my partition table, I say, okay, these are the partitions, and I define that using standard Oracle create table. In the cloud, in Autonomous, we have a new package for you, which is create external partition table. And in here, you can then lay out, okay, I've got partition, I'm going to go by range by col1, and I set out my partition definition, how partition P1 is going to be defined, and point to my, in this case, Ashburn data center to get my, in this case, JSON file. So I'm building a partition table over a data set that's based around JSON, and each of those JSON files will be for a particular range of values. So I know in the first JSON file, if I'm after value 1500, I don't have to go to JSON file 2 or 3, it's only going to be in JSON file 1. So I can get much faster query performance. You can extend that concept even further by having what's called a hybrid partition table. So this is where I have partitions where some of those partitions reside in the database and some of those partitions reside in the object store. And again, file 1 could be in Azure, in a bucket in Azure, and file 2 could be in the Oracle object store. Why would I do this? It seems to be making it very complex, but it's really nice from an end user perspective, because now, in essence, I can look at data that's inside the database, as well as maybe looking at more historical data, which may be in object stores, as a single entity. I don't have to do any joining. I just query one table, and I don't care where the data is. If it's the very latest, the hottest data, it's probably going to be in partition 03. I query that. If I want a little more historical information, like what did I do yesterday, it might be in file 2. And if I want to know what happened on Monday or on Sunday, I might have to go to partition 1. But as an end user, all I do is query one object. So that single table is now straddling the relational world inside my autonomous data warehouse and the unstructured, more flexible world in the object stores. And I'm doing it all within a single table. And all of the usual table constructs apply here in both cases for both hybrid and partitioned external tables. I can make sure that my data is correct. I can make sure that I don't have duplicates. I can put constraints on this, so on and so forth. This sort of hybrid partitioned table, I'm sure already you can start to see some ideas here. So I've got my hot data potentially inside autonomous residing as a table, and then maybe mildly warm in one object store bucket and cold data in another object store bucket. And wouldn't it be nice if, as I moved through time, that the data also went from being inside the data warehouse and said, this is actually warm data or this is cold data, so I'm going to move it for you. Partition maintenance, the life cycle of your data. Stay tuned for progress on that concept of data lifecycle management. If you're doing this, if you have this sort of hybrid structure already on premise, this is probably what you're doing. This is what we've already recognized as a lifecycle management thing within Autonomous Data Warehouse. If you want to try this particular scenario of a hybrid partition table, note that when you go into your Autonomous Data Warehouse, you'll need to be running a 19C version. So if you're not aware today, it's been a while since you created an Autonomous Data Warehouse, in the data centers now, most of them, the newer ones are all 19C anyway, and you'll see that when you create your Autonomous Data Warehouse. Some of the other ones like Frankfurt, Ashburn, we actually have a mixture of 18C and 19C. So when you create it, you'll get the option. So if you want to try hybrid partition tables, either take your existing system and clone it to a 19C environment, or create a new instance and start building that on 19C. Okay, so the syntax for hybrid is pretty much the same. It's just that you're going to have a particular partition. In this case, partition P1. The first partition is going to be within the actual database itself. So it's pretty much the same style as it was before. Why are you going to partition? It's the elimination. That's what you're trying to do. So you know, if I'm going to go for, I want a year's worth of data, and you've got a whole series of data sets in there, you're going to be able to access just the partitions that make sense. So I'm going to only access 4 partitions. Okay, so that's, if you like, the access. So I've got my data lake, I've got all of these systems pushing files into my object stores as my sort of persistence layer for all of these diverse types of data that I'm collecting that have diverse data types, diverse structures, and so on. And I can create different types of tables to go over those that are then allow me to run SQL. So I can now do spatial analytics over that data set. I can do graph queries over those data sets. I can do machine learning over those data sets. If I'm a data scientist, data lake is the new place to go to build all of these data mining models, machine learning models, AI models, and so on. So I can create tables, I can create partition tables to improve my query performance. I can make it even simpler for my end users to access hot data and mildly warm data and cold data through partition tables and hybrid partition tables. The next stage, hence what I had about the safe harbor statement, is could we make that processing when I write SQL and now reach out to my data lake files, could we make that processing even smarter? So there's some smart processing going on for Parquet files that we looked at before. Could I have a similar style of smart processing over all of my data lake files, irrespective of the data type that they are? That's coming. So on the roadmap, we have something called Cloud SQL that we talked about at Open World. So in Cloud SQL, what you'll get is over the top of your object stores, your object store files will be this additional compute, additional very fast scale out processing that's going to understand the SQL that the autonomous data warehouse is processing, and it's going to do some querying, some correlation and processing on those files directly before handing the data back to the autonomous data warehouse. So think of it as similar to zone maps that we already have inside the database, which tell us about information inside the database. This is going to sort of be zone maps on top of my data files. So I'll have things like min and max for columns, number of unique values, and so on and so forth. That's going to help me speed up processing to be able to skip either rows or columns or pieces of data that are not relevant to the query, so that when I send the data back from the lake into autonomous data warehouse, I'm just pushing back the least amount of data possible. The administration of this is going to be very simple. How this gets set up, how it runs, how it knows about the files, etc. in there, that's largely going to be an autonomous process that we will deliver for you, and it's going to be called something called Cloud SQL. Obviously, you're firing up compute on an as-needed basis, so there will be separate cloud charges for using that compute. But the environment itself that you get is going to be part of ADW, ATP, and it will be an autonomous environment. Okay, very quickly, I've got about 9 minutes, I think. I've got the data. I've built these tables now. I've got access to all of my data lake file types. They're all sitting out there in either my object store in Oracle or my Azure object store, or maybe S3. How do I know, other than running a query, is there any other way that I can actually just make sure that when I give this to my business users, or when they attach their analytics cloud or BI tool to that data, that it's actually going to work? And we've naturally given you some validation routines here that can help you check to make sure that everything that you set up actually works, that the data types are right, that if we're using partition tables, that the data goes into the correct placement, the correct partition. But obviously it relies on you mapping the correct files to the correct partitions. Assuming that you've got that right, we'll then be able to give you valid information about, have I got the right partition? Is the data placement right? We'll give you a 1 with this partition validation routine, and a 0 if it's not. So if you ran the partition validation, you will get information back that says, okay, process the file, and yes, correct partitions are in place. There's no values here outside the ranges that you specified. No data's just going to get missed. Everything will function as expected. Now, when you run, oops, just quickly step back. When you run the validate process, what will happen is you'll get 2 files. You'll get a bad file, if there are any records that come out, or a log file as well, which will say, row 3, this file got rejected because varchar 2 insufficient characters, whatever it is. So those will get, so that's processing the data to make sure the data is correct and it fits. The other part was, okay, for a partition table, is it going to arrive in the right partition? Have I defined this right? I'm not going to lose data through my partitioning strategy. The easiest way to test this, is everything set up right? Am I going to get all my data through? Is essentially to try and run this through the SQL Developer Wizard. And it's nice because it'll do a lot of the hard work for you, and it will pick up all of the standard, fairly straightforward error messages that most people typically stumble into. So, for example, did the authentication work? Can we actually see the bucket? Can we see the files? So it'll pick that up very quickly for you. If you get an authentication error, it's usually either going to be the username or the password that you haven't copied in there correctly. So that's always a good place to start. So you might get, say, something like that, authorization failed on my Frankfurt. So either the password's wrong, the username's wrong, or I'm not authorized to see that bucket. So go back and check your credentials. Make sure that you've actually got the username correct from wherever it is, whether you've copied it correctly from the identity keys in S3, or you've got your account name from Oracle Object Store or Oracle's identity management and so on. If you're running it at the command line, you'll see quite useful messages like reject limit reached, which is fairly easy to see. Okay, you can set how many records do I want to reject before I actually call a halt to this whole thing. So don't return any more data. We're going to reject it and abort. And if you know, well, sometimes there are, maybe 2 or 3 records that I'm happy to skip, you can set a reject limit of, say, 3. And as soon as we get over 3, we're going to alert you. We'll stop the whole process. Sometimes it can be a little interesting in SQL developers to try and find these things, because you get a lot more information in SQL Developer coming through. So in this case, what you'll see is, it's told me that it's got an ODCI call out fetch error, and there seems to be a problem with parallel server. The actual problem is that, oops, I've actually just hit the reject limit. So in SQL developers, sometimes we give you too much information about what's just happened. So make sure you read all of the statements. But as I say, here you can, the really nice thing about this system is that you can test. So you can run a test, it will tell you if it's failed, you can see the bad files, the records that come out, it will give you all the information about, okay, so pretty much every row on this got chucked out because cust ID was obviously the wrong data type for whatever reason. So this is a really nice way to get into it and find out what's going on. And you can set the row count, so you can control that. If you look at the bad file, you can then go in and see, okay, cust ID, it's number. It's not a varchar, it's coming through as a number. So you just step backwards, and I can go back through the wizard, change cust ID in the column definition to number, come back in, okay, test it again, success this time. So hopefully we all know what a data lake is now, why it's different to a data warehouse, how it gives us a lot more flexibility, the file formats that we can support, where I put those file formats, where they're going to persist. Typically for Autonomous, that's going to be an object store, preferably Oracle's object store, but we do support other object stores. How you're going to design your schema to access those files based on whether they're chopped up into multiple files, that gives you some control over, can I partition my table to access those different ones? And then having got everything set up, okay, how do I make sure when I hand this over to my BI team, my business users, my report designers, that this is going to work, that I'm actually going to get the correct data through, I'm not going to lose data, I'm going to get the results that I expect. Okay, as I said, as I pointed out in quite a few of these slides here, some of the information that I've talked about is, okay, these are roadmap things, they're coming soon, but they're just a general outline of our product direction. That's all I've got. I've got more slides that I will make available to you.
Thanks, Keith.
Please tune. I'll let Tammy talk about this part and the next couple of slides.
Cool, thanks, Keith. We'll figure out where to post those slides at for everybody to access them externally as well. We really appreciate all the time and great information. I hope that this helps everyone that attended today or listening to the replay on how easy it is to actually access your data outside of Oracle, be able to load it very quickly, be able to access it in the database, and then once you can access it via SQL, then you've got full control of that data, being able to use it for the businesses. So thank you very much. This is great information. So next time on Database Cloud Service Office Hours on March 24th, hopefully Keith will join us again. We're going to talk about using DataSafe along with our security team with Autonomous Database. So if you're interested in finding out how you can manage the security profile of your databases in the cloud much easier with this new service called DataSafe that we introduced at Oracle World last year, please join us on March 24th. Any of the previous recordings can be found at AskTOM.oracle.com. So, there's a lot of good topics we've talked about over the last year. Take a look at those recordings. Also, if you have any questions or any topics that you would like to see talked about on a Database Cloud Service Office Hours, let us know, because we have had some requests and we've been able to get the right people to present on your topic that you're really interested in. So we're really looking forward to hearing from you. Just either post it in AskTOM or please email me, tammy.bednar@oracle.com. I want to thank you for attending today. Again, please tell your friends to subscribe to Database Cloud Service Office Hours so you can get notified of the topics and the next session that we'll be talking about as well. So I know we're over the top of the hour, so I want to thank everybody for joining today, and we look forward to you joining us next time. Thanks, Keith. Bye now.